Hello guys, I'm messing with my stuff again on this oxygen sensor testing. Yesterday when I was doing that test, there's a couple of things that I misspoke. I want to correct myself. At the very beginning of the video I said, this is my, I unplugged my Bank 2 sensor 1, and this is a bias voltage, and I said the sensor is okay. No, this is just a bias voltage. It tells us that harness is okay. Our oxygen sensor is unplugged. So this is not the oxygen sensor testing. This is a testing of the computer, PCM, and the wiring. So then a couple of times I also said that as I was changing the amplitude of my signal, I was saying that O2 sensor is responding. No, the PCM is responding. Again, O2 sensor is disconnected. So this test will be done again if you have a problem where your voltage on oxygen sensor is pegged 0, so you don't know if you have a bad sensor, you have a bad harness, you have a problem with the PCM, so you unplug your sensor, there are no bias voltage, you're still reading 0, so that's where this test will take place. Now, yesterday when I was in the first half of my testing, I was trying to find the amplitude, but the whole time the computer was in the open loop because it was an active code. Now you can see it went back to closed loop, but most of the time it stays in the open loop, and because of the active code, it's never going to go to closed loop, and we're never going to be able to test our PCM, force our signal high or low and see how the fuel trim is going to respond to it. So right now we are in closed loop, but yesterday, and now it's his fault. You can see it goes back to open loop, and at this point we can no longer command our signal high and low, but there will be no correction of fuel trim. So this car is kind of goofy, goes from open to closed today for some reason. Yesterday it was in an open loop all the time. So what I found is that in order to force our car to open loop, to closed loop, we need to clear the code. Let's do that real quick. Let's shut the car off. So we're gonna turn it off. Okay, turn back on, and then we're gonna sorry guys, I'm gonna connect my generator, waveform generator, and now I was really trying to figure out if I can make the yesterday I was making a sine wave from 100 millivolts to 900 millivolts, and all day today I'm trying to find out if I can actually make a signal from the so the computer is gonna change the fuel trim. It just doesn't work. So the only way to do this is basically using the DC volts, increase the signal to 900 millivolts, look for our fuel trim to go negative, and then force it down to 100 millivolts or 0, and see if the PCM is gonna increase our fuel trim to positive. So anyway, so now I have the hook up my waveform generator. Now here I'm just having my like on this modus I have my bank 1, which is going to be good now. Oxygen sensor from Bank 1, and that's going to be yellow trace, yellow channel. I'm sorry, and the green channel is a injector pulse width, and I got the same on the virus, but this is going to be a Bank 2 one that I have my sensor unplugged. So as I said, now since I'm already what the idea behind this is actually to have a signal already going into the PCM from your oxygen sensor harness. Okay, so now we're going to go back And so this whole idea is just to fool the computer so that it doesn't flag the code again, so that you can do your bypass test. So let's go to erase codes. Actually, no, just see what code it had on it. So it had so it has no activity, bank 2 sensor 1, and the heater as well. But most of the time, if you have a sensor signal, it's going to ignore this heater circuit code, and it's still going to go to closed loop. So let's go. Let's erase the codes. Yes. Okay. So now go to live data. Again, this is just to fool the computer, so the computer doesn't see that fault again, and now we can manipulate the signal and test the our PCM for proper. I'm going to go system fuel system status, the close and open loop, bank 1, fuel trim, and then we go to oxygen sensors. And so now we should see. Here you go. So there you go. So this is the voltage that I'm putting into the from my waveform generator. So it's so I'm going to increase it a little bit more, because let's go 2 volts to see what we got now. So it still fluctuates a little bit, but this should work now. There you go. Now it's stabilized. So this is a maximum voltage that computer, actually PCM, can read from the oxygen sensor basically. But now I'm at 2 volts, and it reads 1.1. So now when we start the car, it should see this signal. I'm gonna just change. I'm gonna go back to 1 volt actually. So as I said, right now, and you want a car to already be warmed up, so you don't have to go through the warming cycle. So now this, since we have a signal already getting into the PCM, we should be able to go into the closed loop and stay there, and then we're going to be able to force our signal high and low, and do our PCM response, basically the fuel trim. So let's see if it's should go to closed loop soon. Now this is my oxygen sensor on bank 1. It should start switching pretty soon. It's up high. Let's just, once it warms up, there we go. So now we are in a closed loop, and okay, there you go. So we can see that on bank 1, O2 sensor is it's working. The computer is in control, and so we can see now that. And it's kind of high, so I'm gonna just gonna increase my voltage on my so this is bank. Now we can see that I got my signal completely pegged to 1 volt, and we can see that now computer is taking the fuel away. Our short-term fuel trim and long-term on bank 2 is taking the fuel away according to signal that we are sending from our waveform generator. And I'm gonna reduce the voltage, gonna down, and this is my bank 2. So voltages go down. I can see now that it's gonna start increasing. The green channel here is our injector pulse width. Now I can see it starts to there's too much noise on this. And now we can see that it's going to increase. Let's see. Just have to wait a little bit. There you go. So now our fuel trim should go positive because we force our signal low. And we can see now that on our injector pulse width, it's slowly creeping up as the fuel trim is adding fuel. So as the computer is adding fuel, it's opening the fuel injector. See that? So our pulse width is going the 3-4 millivolts now, and now we can see that our fuel trim is positive. and the computer is responding to oxygen sensor signals. So again, this is just, I'm going to go back to 1 volt again. This is just to, if you guys struggling to get this car, to get a car in a closed loop, just induce the signal, clearly. I'm going back to high signal again, and with this, now these numbers should go down. So it's responding correctly. So we can see on our injector pulse width now it's dropping down to going 3 millivolts. So so this is what I was doing yesterday. This whole time I'm playing with the signal, and then I did that. I'm sorry guys, in another half of the video I said like a bonus footage but I didn't explain what I was doing, how I was able to get into the closed loop and then manipulate my signal to see if the computer is going to respond to it. So okay, so that's what I wanted to show you guys. So if if you're having a hard time to get into the closed loop, you won't do this bypass test, just unplug your harness, plug in your waveform generator, start inducing your like 1 volt signal, clear your codes, and the computer is going to recognize it as a good signal, and it will go into the closed loop. Now we can go back and check our codes. We're probably going to have a still code for heater, but there you go, the heater circuit. But we don't have that code for the signal. That's what kicks the open loop in the still code going to be the same. No still codes. Okay, so that's what it's preventing you from going into the closed loop. Okay, guys. Okay, so this is it. This is quick tip just for you guys to know what needs to be done to do this. Okay, guys. Thank you so much, and see you next time. Appreciate it. Bye.